Sungai Perai, Butterworth, Pulau Pinang. Sungai Perai, Pulau Pinang. Sungai Perai.
Air Sungai Perai.
Sungai Perai pada
Sungai Perai, Butterworth, Pulau Pinang.
Sungai Perai, one of Penang's largest and most significant rivers, is under threat. Once a vital water source and thriving ecosystem, it now faces severe pollution, endangering both human and aquatic life. Spanning across the Seberang Perai region, Sungai Perai play a crucial role in Penang economy and environment. However, rapid urbanization and industrialization have led to a sharp decline in its water quality. Spanning a basin area of approximately 352.43 km² in Seberang Perai Utara SPU and an additional 96.15 km² in Seberang Perai Central, Sungai Perai is fed by several tributaries, making it a significant waterway in northern Penang. For decades, Sungai Perai has been a lifeline for local communities supporting fishing activities, agriculture and industrial operations. More recently, it has been considered as a potential secondary water source for the state of Penang, further emphasizing its importance. However, the river is facing increasing environmental challenges. With rapid urbanization and industrial expansion, Sungai Perai has seen rising level of pollution, threatening its biodiversity and water quality.
My name is Alif and I'm going to present about the causes of pollution in the Perai River Basin. So from the case study, there are 6 major causes that I managed to extract. All the pollution issues is mainly due to several human activities, natural phenomena and weak environmental regulations. So the first major cause is urbanization and industrialization. Over time, areas like Butterworth and Perai have become industrial hubs. However, many industries in these areas discharge untreated waste directly into the river. During rainy seasons, large amounts of industrial waste are washed into the river and worsening its water quality. The second cause is agricultural activities and livestock rearing. Farm runoff carries fertilizers, pesticides and organic matter into the river, while livestock activities contribute to high level of organic pollutants such as BOD and NH3N. The Perai River, which is a tributary of the Perai River, is particularly affected by pig farming in Kampung Selamat, making NH3N a major pollutant in the basin. So another contributor is domestic wastewater or sewage, which comes from the residential areas. Many suburbs and cities lack proper wastewater treatment system, so untreated wastewater is discharged directly into the river. This wastewater contains high level of organic matter and nutrients, leading to increased concentration of BOD and NH3N. Catchments like Selong River and Air Merah River are among the largest contributors to this issue. Next is the tidal effect. The tidal effect in the downstream parts of the Perai River worsen the pollution problem. During high tide, polluted seawater flows back into the river, introducing additional contaminants. This not only increases the level of pollution, but also disrupt the natural flow and self-cleansing ability of the river. Seasonal variations, especially during the monsoon season, which further aggravate the pollution. Heavy rains lead to increased runoff from farms, urban areas and industrial sites, carrying pollutants such as sediments, nutrients and chemicals into the river. These pollutants overwhelm the river's ability to naturally assimilate them. Lastly is poor wastewater management. Many monitoring systems such as water quality index focus only on the river's cleanliness, but do not measure the actual load of pollutants entering the river. Furthermore, existing regulations do not impose strict limits on pollutant discharge. allowing both point and non-point sources of pollution to persist unchecked.
Assalamualaikum, my name is Ahmad Zafran bin Arshad and I'm going to talk about effect of pollution in the Sungai Perai. So the first one is water quality degradation. Water pollution significantly degrades water quality, particularly in rivers like the Perai River, where high levels of biological oxygen demand (BOD), chemical oxygen demand (COD), and ammoniacal nitrogen (NH3N) are present. The main sources of contamination come from industrial waste, agriculture runoff, and residential sewage. Additionally, seasonal changes such as heavy rainfall and tidal effects worsen pollution by increasing pollutant runoff and spreading contaminants throughout the water system. Polluted water poses serious health risks to human and aquatic life. Drinking or coming into contact with contaminated water can lead to stomach infections, skin disease, and respiratory issues. The presence of high NH3N levels makes the water toxic unsuitable for consumption. Furthermore, pollution affects aquatic organisms, leading to toxic buildup in fish, which can enter the food chain and harm human health when consumed. The economic impact of water pollution is also severe, particularly for industries relying on clean water. Fisheries, agriculture, and tourism suffer when water quality declines, leading to job losses and financial instability. Additionally, treating polluted water requires higher costs, which burden both governments and consumers. Moreover, pollution related with health problems result in increased medical expenses and reduced worker productivity, further damaging local economies. Pollution further contributes to climate change, creating a circle of environmental damage. Contaminated water releases greenhouse gases such as methane, worsening global warming. Additionally, extreme weather conditions caused by climate change increase the pollutant runoff, further degrading water quality. Rising temperature also reduce the oxygen levels in water, making it more difficult for aquatic life to survive in polluted environments. Beyond the environmental impact, water pollution severely affects communities, particularly in rural and low-income areas. Many lack access to clean water, forcing them to purchase expensive bottled water and travel long distances to find safe sources. This lack of clean water disrupts daily life, making hygiene and sanitation more difficult. As pollution worsens, public dissatisfaction grows, leading to protests and demands for stricter regulations to address water quality issues.
My name is Muhammad Shahram bin Saidi. My metric number is A21AA0086. I will explain about methodology for total maximum daily load estimation. So in order to create water quality modeling, we are using InfoWorks ICM. So it can simulate pollution trends for biochemical oxygen demand, chemical oxygen demand, and ammonia nitrogen. So it is also a hydrological model that are developed using probabilistic distribution model (PDM), and it also is a model calibration and evaluation with Department of Environment of Malaysia data. So in order to estimate the TMDL, we are using concentration of BOD, COD, and ammonia nitrogen. So there are two formula that are used, which is the first is TMDL is equal to summation of waste load allocation plus load allocation plus margin of safety. The second formula is loading equal to flow rate time concentration. Another approach is load duration curve LDC. So it can categorize pollution load based on hydrological condition, and it is also identify accidents and necessary reduction strategies. My name is Muhammad Shahram bin Saidi. My metric number is A21AA0086. I will explain about methodology for total maximum daily load estimation. So in order to create water quality modeling, we are using InfoWorks ICM. So it can simulate pollution trends for biochemical oxygen demand, chemical oxygen demand, and ammonia nitrogen. So it is also a hydrological model that are developed using probabilistic distribution model (PDM), and it also is a model calibration and evaluation with Department of Environment of Malaysia data. So in order to estimate the TMDL, we are using concentration of BOD, COD and ammonia nitrogen. So there are two formula that are used, which is the first is TMDL is equal to summation of waste load allocation plus load allocation plus margin of safety. The second formula is loading equal to flow rate time concentration. Another approach is load duration curve, LDC. So it can categorize pollution load based on hydrological condition, and it is also identify accidents and necessary reduction strategies.
Assalamualaikum warahmatullahi wabarakatuh and good afternoon to everyone. So today my name is Muhammad Faiz Muhammad Nasir and I will present about the pollution in Sungai Perai, Sungai Jarak and Sungai Kulim. So the objective of this study is to identify the pollution level and purpose pollutant reduction strategies based on the water quality modeling and the hydrological data. So I move to the next key finding. So the first point is in Sungai Perai. So I give a picture example of the Sungai Perai. So Sungai Perai has faced several pollution, especially during the raining season. So the key pollutant here is the ammoniacal nitrogen, which exceeds safe limits and requires 95 or 96% reduction to meet water quality standard. The biological oxygen demand (BOD) also need an 82% of reduction. So the next one is Sungai Jarak. So this is the example situation in the Sungai Jarak nowadays. So the pollution in Sungai Jarak is mainly due to agricultural activities and pig feed farming at the Kampung Selamat, which connect to the Sungai Kerai. So the ammoniacal nitrogen is again a major problem. It's requiring a 94.3% reduction, while the BOD, biological oxygen demand, is 67% reduction to meet the standard. So the last one is Sungai Kulim. Sungai Kulim is the river that face pollution from residential wastewater and small poultry farm. During dry condition, pollutant concentration become worse. The ammoniacal nitrogen require an 89% reduction and the BOD needs 66% of reduction.
So we move to the how we prevent the pollution at the sungai. So how? The first one is controlling. Control pollution at upstream sources by improving waste management in residential and agricultural areas continuously. Regularly check and monitor water quality and manage seasonal pollution fluctuations. Implement strict regulation for farming activities, especially near Sungai Jarak. So the last one is conclusion. In summary, managing pollution in this river requires collaboration between local authorities, communities and industry. By addressing upstream issues, we can ensure cleaner river and protect aquatic ecosystem. Thank you for your attention. Hope to see you again. Thank you.